Hello, discrete math fans. All right, now let's talk about primes and composites. I alluded to this before. So we're going to say that a positive integer n is prime, provided it's bigger than 1, and for all positive integers r and s, if we factor n as r times s, then either r is equal to n or s is equal to n. And we'll say that a positive integer n is composite, provided n is bigger than 1, and n is equal to r times s for some integers r and s. And this time the factorization is such that neither r nor s is equal to 1 or n. All right, so here's some questions. Is 1 prime? Is 2 prime? Is every positive integer greater than 1 either prime or composite? All right, 1 is neither prime nor composite. Now, I alluded to this before when talking about even and odd. 1 falls into a special category that is neither prime nor composite. I promise you that this is a standard definition in mathematics. 1 is not a prime number. The definition of primes and composites requires the numbers to be larger than 1. Now, 2 is a prime number, and we can say that every integer larger than 1 is either prime or composite. Now let's prove this fact. Let's let n be an integer greater than 1. Let's consider all pairs of positive integers r and s such that n is equal to r times s. So we're thinking of all possible factorizations of n. Now there's definitely 2 such pairs. We can have n and 1, n, 1 and n. That's always a way that you can factor. Maybe it's not a very useful factorization, but it is a factorization. That's important to keep in mind. Now, since n is equal to r times s, every possible factorization satisfies the inequalities that r is between 1 and s is between 1 and n. Now, if the 2 pairs that I mentioned, n and 1 and n, if those are the only ways of factoring n, then it's a prime number. That falls under the definition. Now, if there are any other pairs of integers r and s, then neither r nor s would equal 1, in which case we could say that r and s are strictly between 1 and n, and that would make n composite. All right, that's the end of the proof. So we've proven now that every integer that's bigger than 1 does actually fall into one of these categories, either prime or composite. Okay, that's all for now.